So let's jump into this data and an image analysis project. This has been a project that has been haunting me for years. I think we actually started thinking about this in earnest back in 2015. Some of you probably heard me talk about it already, but I'm really happy that it's finally come to fruition. And there's just one small step left in it, but pretty much everything is up and running now, which is really exciting. So I think a lot of you were familiar with how things used to work as far as data in the facility. So we have the acquisition computers that are connected to every microscope. And these are obviously sitting inside the facility up here in Cambridge. So this is going to be very Cambridge-centric. And then outside of all of our offices, we had these data analysis workstations. And at one point, there were 6 of them out there. We then had a dedicated storage server. This was what used to be called CBS Store 01 that we shared with the Center for Brain Science. And that actually sat in a commercial data center that's on top of the Macy's store in downtown Boston. And then a lot of your individual labs also had storage that you'd purchased through research computing that lived there as well. And then Harvard obviously has this big cluster computer that's way out in Holyoke, almost on the border with New York State. So this is what we used to have, and this was a bit of a mess because although we did install, I think this was back in like 2014, 2015, we installed some high-speed fiber optic cables for transferring data around here. This was still pretty messy. This connection between the microscope acquisition computer and the analysis workstations really only worked for the light sheet computer. And then you could send data from any of these computers downtown, but because this was a Linux-based server, it actually limited, and these were all Windows operating systems, it limited the speed that you could actually transfer data at. So it could be a little annoying and it could be a little slow. So we sat down with research computing and tried to figure out what was wrong with this system, and there was a lot. The biggest one was this server was only 400 terabytes, and that wasn't enough. That basically we had to clean it out every January. And like I said, this was also running a Linux operating system, which limited our transfer speeds. Lots of people were just running around with USB drives in between all of these different computers, which was slow, painful, and possibly spreading viruses everywhere. And this meant like your data was always being moved. It usually meant that all of you had about 5 copies of every file, which meant all of our computers were always full. We're always trying to delete data. It was a huge pain in the butt. And then finally, the other pain was that every one of these workstations here had a separate software package or a different Zen module on it, and you couldn't keep straight what was on what. And you're always having conflicts with someone needed workstation 1, but they booked workstation 2, and it was a big pain. So essentially, we came up with 3 goals that we wanted to ensure that we had adequate and expandable storage so that even whatever we bought now, we could expand it if we needed to in the future. We'd come up with some sort of process that limited the amount of data transfers you had to make. And then we really wanted to, and this was, I mean, really pushed by COVID, was provide an easy way to remotely access your data and any of the image analysis software, so that you didn't have to come in and sit in the facility to do your data analysis. So I think, like I said, we're almost there. So this diagram still looks somewhat similar. So what we have now are, we still have the acquisition computers on all of our microscopes. These are changing a little bit in that Zeiss is now offering a 12 terabyte or acquisition computer that you can hook up to your microscope. So we're slowly transitioning to those. I think probably about half of them have that now. And so that's a nice big buffer that's sitting there. So if you're doing a really giant experiment on a light sheet, well, not the light sheet, but on the CD7 or an Axia scan or something like that, there's a really big buffer there where you can send your data. And it's really important that you do save the data directly to the acquisition computer first, because Zen really does not like sending data out over a network, all right? So we're beefing those up a little bit, but that's still going to be the primary spot where your data first lands. The one exception to this is the light sheet. The light sheet does have two dedicated workstations over here, 3 and 4, that you can stream your data directly to. And that's the one situation where this does work well. That's because this microscope runs a special version of Zen Black that's designed for sending data out of there. So once your data is on the D drive of one of these computers, or if you've got some light sheet data on one of these analysis workstations, what you'll see is these computers now automatically map a dedicated storage server. And these storage servers, there's actually 5 of them, but we have 2 or 3 microscopes that are, there's one server dedicated for 2 or 3 microscopes. And this is huge. So we've got about 2 petabytes of storage here now. These all run a Windows Server 2019 operating system. So that means that these data transfers are now a lot faster. And we also went through the entire network from our facility to this server, which is living way out in Holyoke now, and made sure that there was no slowdowns in that network. So it's actually pretty insane. So we have 10 gigabit fiber that comes out of the facility to a closet outside. And then we have 2 40 gigabit fibers out of that closet that goes out of the building to somewhere on Harvard campus, where it then goes into 2 100 gigabit fibers that run out to Holyoke. So some of the transfer speeds here that I've got are insane. It's really only limited by these computers here. So these are usually arrays of 4 hard drives, and sometimes the RAID controllers aren't the greatest on them. So this is usually what's limiting the data storage, but there's a couple times where I've hit like 2 gigabytes a second, which is just insane data transfer to the other side of the state. So we're really happy with that. That works a lot better now. And then the other thing that we've done is right next to this dedicated storage out in Holyoke, we now have 10 what I call remote access workstations. And these are workstations that you can connect directly to from your home, from the lab, lying on your bed, wherever you want. And these are insanely powerful. And so you now can harness that computational power from wherever you want to be. So I think with this setup, we've done a good job of meeting all of our initial goals for this project. So just to tell you a little bit more about what this hardware actually is. So if we look out at Holyoke, I told you we have these 5 storage servers and then these 10 remote access workstations. If you were to look at them in the rack, they look absolutely identical. They're just rack servers. But these ones here are basically built up with a whole bunch of hard drives in them. So it's got about 400 gigabytes of storage on each one. And like I said, we've got 5 of them, and we've assigned each microscope to one of these servers. Right? On the other side, we have these ones that we don't have as many hard drives in them. We actually only have SSD drives in them, so they're really fast for processing data. So there's a lot less storage on here, but a lot more computation. So these have, it's like dual 20-core processors, an insane amount of RAM, and then these absolutely incredible graphics cards in them. So again, there's 10 of these, and these can all be remotely connected to. The idea here is that these storage servers will actually serve as the hard drive for these workstations. And so this connection here between the 2 of them it's something like a 25 gigabit connection. So it's actually faster than a SATA cable in a normal computer connecting to a hard drive. So what that means is you never have to move your data. You take your data on the microscope acquisition computer, you move it to the storage server once, you never have to move it again. When you connect to these remote stations, you just read this like it's a hard drive on the workstation. So this way we've wiped out all the need for moving your data all over the place. Yeah.
Is the LSM 700 currently not assigned to a storage server?
That's correct. Yeah, there's some issues there because that microscope's not on our fiber optic network upstairs, and there's something funky in the network that it doesn't want to connect. So RC hasn't been able to figure that one out, but it's usually pretty small amounts of data.
So you'd still recommend just using like a external drive or something?
Yeah,
to take
you use
okay.
external drive with that one.
Okay.
Yeah. Okay, so how does this actually work? I'm going to try and show you here. So like I said, what you're going to do is save your data to the D drive on the microscope. Obviously, the one exception is the light sheet. You can stream it directly to the workstations outside our offices. And then once you've finished your experiment, you just transfer it to one of the HCBI share servers. And so when you're on a microscope, bad example of a light sheet here, but so you're going to be saving your data to this D drive. You just go into the D drive, create a folder for yourself. And then once that's done, you just drag and drop that folder into the light sheet storage server here. And that's going to send it straight out to Holyoke. All right. If you want to connect to this, so obviously it's automatically mapped on all of our workstations and all of the acquisition computers, and any of the remote workstations that you log into will be automatically mapped. But it's really simple. All you have to do is connect to the RC VPN and then just map that specific server to your own computer. Okay. So if you go to our website, there's step-by-step instructions on how to do this. It's just on the resources tab here. So the resources drops down, says HCBI shared servers, and here's all the step-by-step instructions on how to do this. Okay. So I'm not going to go through that one because I think it's pretty straightforward, but I will go through this process. So when you want to use one of our remote workstations, the first thing you have to do is reserve this in Spinal. And just be careful because the workstations that sit outside of our office are still there. So there's still 4 of them, 3, 4, 5, and 6. And the biggest reason for this is, well, some of these are still on lease. So as the lease ends, we'll get rid of them over time. But right now, we haven't been able to get licenses for the Zen software on the remote servers out in Holyoke. So if you're doing any processing in Zen, you still have to do that at the HCBI. Okay. So there are separate calendars for the workstations that are in the facility, and then these ones that are out in Holyoke. So just make sure when you're making a reservation that you reserve the right one. We still only have 1 license of Ameris. So Ameris is only available on this HCBI View 01 server out in Holyoke. Other softwares are available on the other systems there. Okay. So your step 1 is to go into Spinal and make a reservation. And then the next thing you do is, again, connect to the RC VPN, and then you're going to use Windows Remote Desktop to connect. So once again, all these instructions are on our website. Resources tab, there's a tab that says Remote Workstation Connections. But what I'm going to do is I'm just going to try and show you how this works real quick.
Hey, Doug.
Yeah.
Is Zen going to eventually be on these remotes or no?
We are hoping so.
Okay.
Yeah. Yeah. We have another meeting with Zeiss next week about it. Okay. All right. So first thing is just connect to the RC VPN. It's going to ask for your password. It's going to ask for your second password. It's probably on your phone or your desktop through the authenticator. Okay. And then, here. Then you just open up remote desktop connection. If you're on a Mac, there's a version of this that you can download for your Mac. So I'm just going to connect to this one, HCBI View 02. One thing to be careful with here is this will initially default to just your local account on your computer on whatever you're on. So you have to go into this extra options, just make sure you add the rc./ here so that it goes to the RC domain. And then hit connect. Then it's going to ask you for your RC password again. And then it's going to connect. We don't have a security certificate on it, don't worry. And of course, it's brought it up on my other screen here. Okay. Okay, so this is it. This is the remote server that we're on right now. You can see there's a bunch of different softwares that are already on here. Like I said, the Zen's there, but it's not going to work for you because it doesn't have a license, so you only get the free version of it. But if we go into Arevis here, Arevis, what we have are 3 full licenses, and then there's 2 or 3 of these visualization licenses, which allow you to look at your data, just not do any processing. So as long as there are no more than 2 other people using Arevis at the same time, you can just click on the top one here and get the full one. If those are full, you just want to look at your data, then you can take a look at the bottom one here. So this is a data set that Heather, Tabby, and Alex took the other day. So this is just opening up Arevis. It's going to load that entire data set onto the graphics card that's out there. And then once that's done, you'll see that this is actually, the interaction with this is just like it was on my own computer here. It's kind of crazy. So this is a pretty big data set. Oh, now it's going to be laggy. So I was trying this at home last night, and there was a bit of lag like this because I think my kids were watching Netflix and my wife was on her computer doing something. I just tried this upstairs in my office before I came down over Wi-Fi, and there was no lag at all. If you're plugged in with an Ethernet cable on your computer, then you're going to be totally fine. Very little lag at all. And this is, I mean, a pretty big data set. It's an entire mouse brain. So yeah, it works very well. And then one important thing is when you're done on here, it's very tempting to just close desktop connection. You can't see it behind the Zoom bar here, but there's an X to close out up there. If you do that, it doesn't actually log you out of the server, and then we just get a whole bunch of people piled up inside. So just make sure that you actually go in and log out this way. Okay, cool. So are there any questions about that?
Yes. Is it possible to remote in from Linux, or do you need to use the Windows?
That's a good question. I don't know if there's a version of Windows or Windows Remote Connection for Linux.
Okay. But like you can't just SSH into these servers, right? There's no.
Yeah.
Okay.
Yeah. Okay. Good. So, like I said, right now, Amaris and MATLAB are only on that HCBI View 01. Zen right now is only available on workstations 3 through 6 in the facility, but all of the other ones have Arevis, Fiji, Cell Profiler. If there's anything else that you're interested or want us to put on there, just send us an email at the general account here, and we can get that added to those workstations. All right. So just a couple other notes. Just make sure when you're on those remote workstations, don't save any of your data to the CRD drives. They're really small. They're only meant for temp files that are written there. All of your data should remain on one of the HCBI share servers and just be read in and written out from that remote desktop. Like I said, always sign out of Windows. Don't use Switch User or just close the remote desktop app. And don't forget to make your reservations in Spinal, just like you had to do before.